Okay, so now that we've talked about how to use the periodic table to determine the charges on these monoatomic ions, let's take a look now at how we can combine these ions to make these ionic compounds. Okay, and the key thing that you want to keep in mind when we combine these is the following. When you combine them, you need to make sure that the charges, so those are the positive charges and the negative charges, have to cancel out. So in other words, an ionic compound, any compound in general, must be overall neutral. So let's take a look at a couple simple examples, and then we'll show you some shortcuts to get to the same answer. So let's say I have sodium. So sodium is Na, and then I have chlorine, and chlorine is Cl. So based on what we talked about previously, right, we can determine the charges on the sodium atom. Sodium's a metal, so we know it's going to be positive. It's in group 1, so it's 1 plus. Chlorine is a non-metal, so we know if it forms an ion, it'll be negative. It's in group 7, so for the non-metals, it's a group number 7 minus 8. That gives me 1 minus. So these are the ions that I need to combine. And I'm going to combine them so that the charges, the plus 1 plus and the 1 minus, that they cancel out. Now, obviously, all I need to make sure these charges cancel is I would need 1 sodium, which has a 1 plus charge, and I also need 1 Cl minus because these, the 1 plus and the 1 minus, will cancel. So when I put these together and I write the formula then for the combination of this ionic compound, I always write the metal or the cation first, so Na, and then I write the non-metal or the anion second, Cl, and then I use subscripts to tell me the ratios of the cation to the anion such that the charges cancel. All right, so I need a 1-to-1 ratio here. So I put the 1 sodium to the 1 chlorine. That's my ratio, right? Ones are understood, right? We write them in as subscripts, but they're understood in this case. I don't need to put the ones in. So to clean this up, what I end up with is just NaCl. Okay, there's no charges, there's no superscripts in your final formula for this compound. If you have just one of the elements, okay, you can omit the one, just don't put 0. That means there's nothing there. So we end up with NaCl, right? That tells me that they combine in a 1-to-1 ratio. So the charges cancel out. Let's take a look at another example. Let's say I had, let's say calcium, and let's say I had the chlorine again. Okay, so calcium is Ca, chlorine we know is Cl, and we know also that chlorine will form a 1 minus charge. Calcium is in group 2, it's a metal, so it'll be 2 plus. So now we can see in order for these charges to cancel, right, if I have one of each, they're not going to cancel out. I actually need 2 of the Cl minuses to give me a total here of 2 minus to cancel out the 2 plus. So my ratio here is 1 calcium ion to 2 Cl minus ions. And the way that I would write that as my formula would be Ca1 and then Cl2, right? These are my ratios, and I'm going to clean this up. I don't need the 1. 1 is understood, so it simply is CaCl2, right? That's your formula for that. Now, let's take a look at a little shortcut we can use to help us figure out these formulas. So shortcut for determining these formulas. And this is sometimes called the crisscross. Oops, I can spell that, crisscross, or the cross charge method. Okay, and it works really simple. The first thing we need to figure out is what are the charges of the ions involved? All right, so let's say we'll do the same one we did previously. So we have calcium, which you know has a 2+ charge, and then we have chlorine with a 1-. All right, so first thing, figure out the ions. Then we're going to write the formula. So the cation goes first. So we have Ca, and then we have Cl. And the way the crisscross works is the charge on the metal, so the 2 here becomes a subscript on the non-metal, and then the charge on the non-metal, which is the 1, becomes a subscript on the metal. So I end up with Ca1, Cl2. Again, the 1 is understood. So if I clean this up, I end up with CaCl2, which is the same formula I came up with up here. Okay, that's a quick way to determine your charges. We take a look at maybe a couple other ones, because there's one other layer we need to consider, which we'll address here in a second. Let's say that I had, let's do aluminum and oxygen. Okay, so aluminum is Al. Aluminum is a metal. It's in group 3. So it's a metal. It's going to be positive. It's in group 3. It's just 3 plus. Oxygen is O. It's a non-metal. So it's going to be negative. It's in group 6. So the charge there is 6 minus 8, which would be 2 minus, right? So we can quickly determine charges. And when I do my cross or crisscross method now, I have put the cation first, so Al, anion goes second. And now when I do my crisscross, the 3 here for the aluminum, that becomes a subscript on the oxygen. And then the 2 for the oxygen becomes a subscript on the aluminum. So this is telling me the ratio that will provide, that will allow these charges to cancel would be 2 aluminums and 3 oxygens. You can confirm that. If I have 2 aluminums, 2 times 3 plus gives me 6 plus total positive charge. And if I have 3 oxygens, 3 times 2 minus gives me 6 minus. Okay, they are going to cancel out. So this is the smallest, or the simplest whole number ratio is what we're looking at here. All right, and we'll take a specific look at why we need this whole number ratio here in a second. So let's do another one with the smallest whole number ratio. Let's take another one. Let's do, we'll do barium. And we'll do oxygen again. Okay, so we already know oxygen is going to form a 2 minus from the one above. So O is 2 minus. And then barium is Ba. Barium is in group 2, just like calcium is. Okay, it's a couple elements further down. So if in group 2, and it's a metal, so it's going to be positive, group 2 would be 2 plus. So if I do my cross charge again, metal, non-metal, I write their formulas, so their symbols. And then if I do my cross thing, the 2 here becomes a subscript on the oxygen. The 2 on the oxygen becomes a subscript on the barium. Now, if you do your crisscross and you end up with whatever you get, what you want to try to do is you want to simplify. You always, for ionic compounds, you always want to simplify the ratio. All right, so in other words, can I simplify a 2 to 2 ratio? And the answer is yes. 2 to 2 is the same as 1 to 1. So this then becomes BaO. Right, the way that I simplify it is I can divide both of them by 2. The lowest common multiple of each of those. So they cancel out, and you end up with 1. And this is how we end up with BaO as your final answer. Right, you don't want to leave it as Ba2O2. No, you want to get the smallest whole number ratio possible for your ionic compounds. Okay, and that's the subscripts that we're looking at. So this is a quick way, once we can figure out, use the periodic table, figure out your charges, do your crisscross to get the formulas for these. So the next thing we're going to take a look at is how we name these compounds. All right, so let's see, I have NaCl, CaCl2. We'll just list these that we just did previously. Okay, so naming ionic And we're going to call these binary ionic compounds. They're just going to be made up of two different types of elements. And we're going to name them as we see them. So as they are written, in other words. Okay, but there are rules that we're going to follow. These are systematic rules, which means that everybody follows the rules so that we know exactly what we're talking about. So let's take a look at the first one. We had Na and we have Cl, right? So as it's written, Na is first, Cl is second. So the first element gets the name, the metal, and we name it as it is. So it's just sodium. The second name comes from the other thing that's there. So the Cl, so Cl is normally chlorine, right? But you don't want to write chlorine because chlorine implies that it's just an atom. As we've established already, these are not atoms, these are ions. So the chlorine ion is actually called chloride. So we need to drop the ending and replace it with the IDE. Okay, so this NaCl is actually called sodium chloride. Okay, so it's got that ending. And that's commonly known, that's table salt, by the way, but sodium chloride is the proper name for it. All right, if we have something like, I think the other one was CaCl2, okay, we're going to name it very similarly. So first element here is the metal, so we name the metal as it is. We don't do anything to the name calcium. And then again, Cl as a last name would be chloride. Okay, the fact that there's a 2 there doesn't really impact my name. It's just calcium chloride. If we take a look at, what do we have? Al2O3. We'll name that one. Okay, again, first name is the Al, which is aluminum. And then O is oxygen. Okay, but it's not aluminum oxygen. We need to drop the ending just like we did above. So the YGEN, and we replace that with I. So then this becomes aluminum oxide. Okay, so oxygen as a last name is oxide. We'll do one more here. Let's say that we had something like, do a different one. Let's do Mg. So let's say magnesium, and let's combine it with nitrogen. Okay, so we're going to go through all the steps now, determine the charges on the ions, combine them in the correct ratio, and then name the resulting ionic compound. So magnesium, Mg, it's in group 2, and it's a metal, so it's going to be positive because it's a metal. It's in group 2, so it's 2 plus. Nitrogen is N, it's a non-metal, so we know the charge is going to be negative. It's from group 5, so 5 minus 8 gives me 3 minus charge. All right, we're going to combine these. We can do the crisscross, cross charge, whatever you want to call it. So we have our Mg, we have our N. So the 2 here, and the Mg becomes the subscript on the nitrogen, and then the 3 becomes the subscript on the magnesium. So we have Mg3 and 2. So when we name it, first name comes from Mg, which is just magnesium. Okay, and then N is nitrogen. So just like in the previous example, we're going to drop the ending here, the O-gen part of it, replace it with IDE. So we end up with the correct systematic name for this as magnesium nitride. Right? So all of these, all the examples we looked at had that IDE ending that you want to include when you name these binary ionic compounds. Okay, so this is, again, we're not going to get too deep into the nomenclature or how we name things, or in some of the other things here. We're just going to touch the surface on how to interpret these formulas, what they actually mean, and how do they result in the first place, right? So it all boils down to the electrons and stability. So these metals will want to lose electrons to become more stable. As they do that, they form positive ions or cations. Non-metals want to gain electrons to become more stable. By doing that, they form negative ions called anions. And the attraction between the positive and negative ions, that is what the ionic bond is. We can put them together in the right ratio so that the charges cancel. We represent the ratios as subscripts, and then we can name them according to our rules.